So we're going to find the antiderivative of x squared sine of x dx, and we're going to use integration by parts. Now, we'll actually need it twice because of the x squared, because it's going to take 2 rounds to get rid of that x squared. So let's see what that'll look like. So we're going to let u be the x squared, and we're going to let dv be the sine of x dx. Now whether we take derivative or antiderivative of sine, it stays about the same. It's always going to be a trig function. So that's our note that we might want to try our u as x squared. Now the antiderivative of sine x is negative cosine of x, and the derivative of x squared is 2x dx. So putting that together in our integration by parts, we have u times v, which is a negative x squared cosine of x minus the integral of v du. So that'll give us negative cosine of x 2x dx. Now what I'm going to do is I'm going to clean up my constants here and pull them out and see where I'm at. So I have the negative x squared cosine of x. That part is done. A negative negative will become a positive, and I'm going to pull the 2 out as well. And I'll write the x out in front just so it looks similar to what we started with, cosine x dx. So here is the integral we have to complete now. This will require another round of integration by parts, and we're going to let u equal x, and we're going to let dv equal cosine x dx. Therefore, our du is dx, and our v is sine of x. So this one's not too bad. Now here's where you have to be a little careful. You have that 2 out front. So when I put in my next round of integration by parts, it all needs to get multiplied by the 2. So I've got my uv, which is x sine x minus the integral of v du sine of x dx, and I have that in a set of parentheses. So lastly, I've got minus x squared cosine of x, plus 2. This part again is now done, x sine x. Now the antiderivative of sine is negative cosine. We had done it up here. And so minus a negative cosine is going to be plus cosine of x plus c. We don't need to worry about multiplying the c by 2 because it's just some arbitrary constant. Now to clean things up, we may decide to go ahead and distribute that 2, although it's not necessary. Our antiderivative is correct. But let's just go ahead and do it here. Plus 2 cosine x plus c. There's no terms we can combine, so that's as far as we can go. And we can always check this antiderivative by taking the derivative, and we should get back to where we started.